Okay, welcome everybody to the first snippet of exam tutorial question revision. Okay, I created this to help you to understand some of those more challenging topics, and I'm sure you will find this series of video useful. So this round I'm going to touch on the use of FullAdder. How can we use the FullAdder to perform binary addition of two numbers, and these numbers can be of varying length, to be 3-bit, 4-bit, and 5 bits. Okay, but before I show you how to do it, let's first of all touch on the concept of a FullAdder. What does a FullAdder do? Okay, basically a FullAdder helps you to perform the binary addition of 3 binary numbers, each numbers being 1 bit in size. So for example, you could be trying to add 101. Okay, so let me just draw something on the screen. So for example, if you try to add 101, okay, and what is the result? 1 plus 0 plus 1. Answer is 2, right? Yeah, 1 plus 0 plus 1 is 2. 2 expressed in binary is actually equivalent to 1, 0. Okay, so we're talking about binary addition here, so we leave the answer as 1, 0. Okay, let's call this the sum, and let's call this the carry out. Okay, and so what the FullAdder does is to help you to produce this result, the carry out and the sum. So in this example, you have you're trying to add, let's call this A, call this B, let's call this C, this input C in. Okay, so we are trying to add 1 plus 0 plus 1, 1 plus 0 plus 1, and we would have designed some complicated circuitry, being some combination of AND gates and XOR gates and so on. Okay, and connected together in series and whatever. So that's not important. Okay, we will not discuss how to design that AND gate or all the logic circuit in this tutorial, but suffice to say that to understand what a FullAdder helps you to do based on some designs of AND gates and OR gates. And so 1 plus 0 plus 1 results, you should expect the result to be a 0 for the sum, and carry out to be a 1. Okay, let's change another take another scenario. Let's say 1 plus 1 plus 1. Let's add them together. What do we expect the answer to be? 1 plus 1 plus 1. Of course, it's 3. And how do you represent 3 in binary? It's 1, 1. Okay, 1, 1. So let's call this is the sum, this is the carry out. Okay, so in this scenario, so if you were to input a different input condition to this FullAdder, this is the FullAdder. Okay, now we change the condition to 1 plus 1 plus 1, 1 plus 1 plus 1. And the answer will be different now. The output will be different. The output will be 1 for the sum and a 1 for the carry. So that's the whole idea. Okay, a FullAdder helps you to perform help you to add 3 binary number, and each binary number is 1 bit in size. It's only 1 bit in size. Later we'll show you how you can use a FullAdder to add 2 binary numbers, and then binary numbers could be more than 1 bit in size. Okay, so let's try to fill up all the input conditions, all the possible ways to add three binary numbers together, each numbers being 1 bit in size. So let's fill up the inputs of the truth table. And so I hope you still remember, first rightmost column of the input condition, fill it up with alternating zeros and ones. Okay, the second rightmost column, fill it up with alternating zeros and 11s. And the rightmost column, fill up with the next column filled up with alternating 0, 0, 0s and 1, 1, 1, 1s, and so on. Okay, and so take for example just now the addition. Okay, if the input condition is 1, 1, 1, okay, this is your A, this is your A, this is your B, this is your C, C in. Okay, if the input condition is 1, 1, 1, you expect the output to be a 1, sum carried out to be a 1. Output to be a 1 carried to 1. This is the input condition. Look at this input condition. 1, 0, 1, 1, 0, 1. Okay, look at 1, 0, 1. 1, 0, 1, where's my 1, 0, 1? Yes, 1 plus 0 plus 1. Okay, you expect the output to be a 1, 0. Okay, and so on. You can start adding. 0 plus 0 plus 0. Sum is a 0, carry is a 0. 0 plus 0 plus 1. Sum is a 1, carry is 0, so on. 0 plus 1 plus 0. 0 plus 1 plus 1, answer is a 2, so it's 1, 0. 1 plus 0 plus 0, answer is a 1. 1 plus 1 plus 0, answer is a 2, so answer is 1, 0. And here you've got the truth table. And with this truth table, you can start designing the circuit diagram, and you should have a diagram. Refer to the lecture notes slide, you can take a look. It is formed up of made up of XOR gates, AND gates, and OR gates. But what I want to focus on in these snippets is not the full adder, it's just a quick revision. Let me move on to the next topic, next part, which is how can we use the full adder to perform binary addition of two binary numbers which is more than 1 bit in size. Let's say